On the morning of May 8, 1945, Field Marshal Wilhelm Keitel walked into a Soviet military headquarters in Berlin-Karlshorst to sign Germany's unconditional surrender. The ceremony was brief and humiliating. Keitel wore his full-dress uniform with all his medals, attempting to maintain the dignity of the officer corps he represented. But as he entered the room and saw the Allied representatives waiting, something caught his attention that made him pause. Among the Soviet, British, and French officers stood representatives of the United States Army Corps of Engineers. They were not there by accident. They were there because American engineers had built the material foundation for Germany's defeat, and German commanders knew it. What Keitel witnessed in that room was the final confirmation of warnings German military intelligence had been issuing since 1942. Warnings about American engineering capability that had been ignored, dismissed, or simply disbelieved until it was far too late. This is the story of what German generals and field marshals said about American engineers, both before they understood the threat and after they had been buried under the evidence of their mistake. The warnings began earlier than most people realize. In the spring of 1942, German military intelligence officers assigned to assess American industrial capacity started filing reports that made uncomfortable reading in Berlin. These were not propaganda documents meant to demoralize the German war effort. These were sober technical assessments compiled by engineers and economists who had studied American industry before the war. One particular report, filed in March of 1942 by the Economic Warfare Section of the Oberkommando der Wehrmacht, Germany's High Command, contained a section that should have terrified anyone who read it carefully. The report noted that the United States possessed more registered engineers than Germany, Britain, and the Soviet Union combined. American universities graduated approximately 15,000 engineers every year. German universities graduated fewer than 3,000. But the numbers only told part of the story. The German report noted something more concerning. American engineers were trained differently than their European counterparts. European engineering education emphasized theoretical knowledge and classical mechanics. Students spent years mastering mathematical principles before applying them to practical problems. The result was highly educated engineers who excelled at optimization and refinement but sometimes struggled with rapid innovation under pressure. American engineering education took a different approach. Theory mattered, but practical application mattered more. American engineering students built things. They worked in machine shops. They designed projects that had to function, not just calculate correctly on paper. They learned to improvise, adapt, and solve problems with whatever materials were available. The German intelligence report noted this distinction but failed to grasp its significance. The authors treated American practical training as a sign of intellectual inferiority. They assumed that American engineers lacked the theoretical rigor of their German counterparts. This assumption would prove catastrophically wrong. What the Germans interpreted as lack of sophistication was actually a different kind of expertise. American engineers were trained to build things quickly, efficiently, and at scale. They were trained for exactly the kind of war that was about to unfold. General Franz Halder, chief of the German Army General Staff until 1942, later admitted that German intelligence had completely misjudged American engineering education. In post-war interviews, he explained that German officers assumed engineering capability correlated directly with theoretical sophistication. They believed that because German universities taught more advanced mathematics, German engineers must be superior. They never considered that building a Bailey Bridge under enemy fire required different skills than designing a suspension bridge in peacetime. The first real shock came in North Africa. When American forces landed in Operation Torch in November of 1942, German commanders in North Africa were not particularly worried. The German Afrika Corps under Field Marshal Erwin Rommel had been fighting the British for over 2 years. German officers had developed considerable respect for British infantry and artillery, but they had also learned British weaknesses. British logistics were slow. British engineering units took time to establish supply lines. British commanders were cautious about advancing beyond their prepared positions. The Americans, German intelligence suggested, would be even worse. They were inexperienced, poorly trained, and soft from years of peacetime comfort. The first American units to face the Afrika Korps at Kasserine Pass in February of 1943 seemed to confirm these assumptions. American infantry broke under German assault. American tank crews made tactical errors that cost them dearly. American commanders showed inexperience in coordinating combined arms attacks. Rommel's forces inflicted a humiliating defeat on the Americans at Kasserine. German after-action reports praised the fighting quality of German soldiers and mocked American tactical incompetence. But buried in those same reports was a detail that would prove far more significant than the tactical victory. German engineering officers noted that American supply lines had been established with astonishing speed. Roads that should have taken weeks to build appeared in days. Airfields that should have required months of construction were operational in under 2 weeks. Fuel dumps, ammunition depots, and repair facilities seemed to materialize overnight. One German engineering officer, whose report was captured after the war, described watching American construction equipment work. He had never seen anything like it. The Americans used massive earth-moving machines that could reshape terrain faster than he thought possible. Bulldozers cleared obstacles that would have required days of manual labor by German pioneers. Graders leveled roads with precision that German horse-drawn equipment could never match. Cranes lifted loads that would have required elaborate pulley systems and dozens of men. The officer's report was filed and apparently ignored. The tactical victory at Kasserine mattered more to German commanders than logistical observations from engineering staff. This was a mistake that would be repeated throughout the war. German military culture valued tactical excellence and operational brilliance. Logistics and engineering were important but secondary concerns. The Americans had inverted this priority structure, and German commanders did not understand the implications until far too late. By May of 1943, the Afrika Korps was finished. Trapped in Tunisia, cut off from supply, and facing overwhelming Allied superiority, over 250,000 German and Italian soldiers surrendered. It was a catastrophe comparable to Stalingrad. Among the captured documents were engineering assessments that painted a disturbing picture of American capabilities. German engineering units had been tracking American construction activities throughout the North African campaign. What they documented was industrial warfare on a scale Germany could not match. The Americans had built or improved over 2,000 miles of roads in North Africa. They had constructed dozens of airfields capable of handling heavy bombers. They had established port facilities that could unload more tonnage in a day than German-controlled ports could handle in a week. They had laid thousands of miles of communication wire, installed water purification systems serving hundreds of thousands of troops, and created supply networks that functioned with mechanical precision. One captured German report tried to quantify what this meant. The author calculated that American engineering units in North Africa had accomplished in 6 months what would have required German units 2 years to complete, and that assumed German units had access to equivalent equipment, which they did not. The report concluded with a warning. If the Americans could build this rapidly in the difficult terrain and climate of North Africa, what could they accomplish in Europe? The answer came in Sicily and then Italy. When Allied forces invaded Sicily in July of 1943, German defenders expected the usual Allied pattern. Cautious advances, careful consolidation, slow progress as logistics caught up with the front line. Instead, American engineering units seemed to move as fast as the combat troops. Roads damaged by German demolitions were repaired within hours. Bridges destroyed to slow the Allied advance were replaced with temporary spans before German commanders had finished congratulating themselves on the delay they had caused. Field Marshal Albert Kesselring, who commanded German forces in Italy, was one of the first senior German officers to truly grasp what American engineering capability meant for the war. Kesselring was an Air Force officer, not an Army general, and perhaps his different professional background gave him a different perspective. He understood logistics because the Luftwaffe had always struggled with supply issues. He understood industrial production because air forces were the most industrially intensive branch of modern militaries. Kesselring watched American engineers work in Sicily and understood that Germany faced something unprecedented. In a report to the High Command in August of 1943, he warned that American engineering units were not support troops in the traditional sense. They were combat multipliers that fundamentally changed the pace and character of warfare. He noted that American engineers could construct a temporary bridge capable of handling 30-ton tanks in under 12 hours. German pioneers required 2 to 3 days for equivalent construction, and that assumed they had the materials and equipment available. More concerning, Kesselring observed that American engineering seemed to operate with unlimited resources. When German units destroyed a bridge, American engineers did not repair it. They built a new one next to it, or sometimes they built 2 new bridges and left the destroyed one in place. This was not inefficiency. It was overwhelming material superiority translated into tactical advantage. Why spend time repairing a damaged bridge when you could build a new one faster than repairs would take? The Italian campaign became a grinding attritional struggle that lasted from September of 1943 until the end of the war in Europe. German forces fought skillfully, using Italy's mountainous terrain to create defensive positions that should have been nearly impregnable. Kesselring established defensive lines across the Italian peninsula that took full advantage of rivers, mountains, and limited road networks. The Gustav Line, anchored on Monte Cassino, held the Allies for months. But American engineers systematically negated every geographic advantage Germany possessed. Rivers that should have halted Allied advances for weeks were bridged in days. Mountains that should have channeled attackers into killing zones were bypassed by roads built through supposedly impassable terrain. Coastal routes that German artillery had zeroed in on were supplemented by inland roads that did not exist on German maps because they had not existed until American engineers built them. A German officer defending Monte Cassino recorded his observations in a diary later captured by Allied forces. He described watching American engineering vehicles working under German artillery fire. The Americans did not stop when shells landed nearby. They did not take cover and wait for the bombardment to end. They kept working. If a vehicle was hit, another one took its place. If engineers were killed, more engineers arrived. The work continued 24 hours a day under floodlights at night. The officer had fought on the Eastern Front against the Soviets. He had witnessed Soviet human wave attacks that accepted horrific casualties to achieve objectives. But this was different. The Soviets threw men at problems until the problems were solved or the men were gone. The Americans threw machines at problems until the problems were solved, and the machines never seemed to run out. By early 1944, German commanders in Italy were filing reports that tried to quantify the engineering disparity they faced. One assessment calculated that a single American engineering battalion could accomplish more construction work in a month than an entire German pioneer regiment could achieve in 6 months. The calculation was based on observed performance in Italy, not theoretical estimates. The report noted that the disparity came from 3 factors. American engineers had more and better equipment. American engineers had more raw materials available. And American engineers used standardized, prefabricated components that could be assembled rapidly rather than custom-built for each situation. The clearest example of this approach was the Bailey Bridge, a British invention that American industry produced in enormous quantities. The Bailey Bridge was a modular design that used standardized steel panels bolted together to create spans of varying lengths and load capacities. The components were simple enough that minimally trained soldiers could assemble them. The design was strong enough to handle the heaviest tanks. And the bridges could be built quickly under combat conditions. German pioneers had nothing equivalent. German bridge building relied on custom engineering for each site. Engineers surveyed the crossing, calculated load requirements, designed an appropriate structure, and then built it from available materials. The process required skilled engineers, substantial time, and significant resources. A Bailey Bridge could be assembled in hours by soldiers following a simple instruction manual. A German custom bridge required days or weeks and specialized engineering supervision. German commanders quickly learned to fear Bailey bridges. These ungainly-looking structures appeared across every river, stream, and ravine in the Allied path. German artillery would destroy a Bailey Bridge, and another one would be standing in the same place the next morning. Kesselring remarked bitterly that the Americans seemed to have an infinite supply of these bridges, and he was not far wrong. American factories produced thousands of Bailey Bridge panels. Supply ships carried them to Italy by the ton. Engineering units stockpiled them near the front lines. When a bridge was needed, it was assembled. When a bridge was destroyed, another one was built. The invasion of France in June of 1944 brought the full weight of American engineering capability to bear on the German army. The Normandy landings were the largest amphibious operation in history, and they succeeded in part because of engineering preparations that German intelligence had failed to detect or comprehend. The Allies had constructed 2 artificial harbors called Mulberry Harbors. These enormous prefabricated ports were towed across the English Channel and assembled off the invasion beaches. Each Mulberry harbor could unload more cargo than major European ports like Cherbourg or Le Havre. German military intelligence had known that the Allies were planning an invasion. They had dedicated substantial resources to determining where and when the attack would come. They had built extensive fortifications along the Atlantic coast. But they had completely failed to understand the engineering dimension of the Allied plan. The idea of building temporary ports and towing them across the Channel seemed too ambitious to be credible. German engineers calculated that such a project would require years of construction and enormous resources that could better be used elsewhere. The Allies built the Mulberry harbors in months and used them to solve the biggest problem of amphibious warfare: how to sustain forces ashore before capturing a major port. The engineering genius was not in the concept, which was relatively straightforward, but in the execution. Standardized components, mass production, and careful logistical planning turned an ambitious idea into operational reality. Within weeks of the D-Day landings, American engineering battalions were building infrastructure across Normandy at a pace that German commanders found difficult to believe. The Americans constructed or improved over 3,000 miles of roads in France during the summer of 1944. They built fuel pipelines that carried millions of gallons of gasoline from the coast to supply advancing armies. They established depot systems that could store and distribute supplies for millions of soldiers. General Gunther von Kluge, who commanded German forces in France after the invasion, sent increasingly desperate reports to Berlin about the impossibility of stopping the Allied advance. His tactical situation was bad enough. Allied air supremacy made daytime movement suicidal. Allied artillery outgunned German batteries. Allied tanks outnumbered German panzers. But von Kluge kept returning to a theme that higher command seemed unable to grasp. The Americans could build faster than Germany could destroy. German forces would demolish a bridge to slow the American advance. American engineers would have a temporary bridge in place before German forces could fully exploit the delay. German units would crater roads to make them impassable. American bulldozers would have the roads repaired within hours. German artillery would shell American supply dumps. New supply dumps would be established before the shelling ended. Von Kluge tried to explain to Berlin that traditional defensive tactics were failing because they assumed that destruction created delays that could be measured in days or weeks. Against American engineers, destruction created delays measured in hours. The operational tempo of the war had changed, and German forces could not adapt quickly enough. The breaking point came during the pursuit across France in August and September of 1944. After breaking out of the Normandy hedgerows, Allied armies raced eastward toward Germany at speeds that resembled the German blitzkrieg of 1940. But there was a critical difference. The German blitzkrieg of 1940 had outrun its supply lines and been forced to pause. The Allied advance of 1944 never paused because American engineers kept the supply lines moving forward at the same pace as the combat troops. The Red Ball Express became legendary, a convoy system that ran continuously from Normandy to the front lines, delivering thousands of tons of supplies every day. But the Red Ball Express only functioned because American engineers maintained the roads it traveled. Every bridge had to hold the weight of loaded trucks. Every road surface had to support continuous heavy traffic. Every intersection had to be marked and controlled. American engineering battalions worked around the clock to keep the supply route functioning. German commanders who witnessed this system in operation described it in terms that revealed their incomprehension. One panzer general, captured in late August, told his American interrogators that he had watched an unbroken stream of American trucks moving east for over 6 hours. He had counted approximately 1,200 vehicles in that time. Each truck carried supplies forward and returned empty for another load. The multiplication was simple. If 1,200 trucks passed in 6 hours, and the convoy ran 24 hours per day, that meant nearly 5,000 truck trips daily on just one route. The general had commanded panzer divisions that struggled to receive 50 trucks of supplies per day. His entire corps received less supply tonnage in a week than this single American convoy route delivered in a day. He told his interrogators that he had finally understood why Germany was losing the war. It was not courage or tactical skill. German soldiers were as brave as any troops in the world. German officers were tactically competent. But Germany could not build roads fast enough, could not maintain trucks in sufficient numbers, and could not deliver supplies at the scale required to fight the kind of war that modern technology demanded. The American engineers had solved these problems not through brilliance but through systematic application of industrial principles to military logistics. Standardized vehicles meant standardized repair procedures. Prefabricated bridge components meant rapid river crossings. Abundant construction equipment meant roads could be built or repaired faster than combat could damage them. It was engineering as overwhelming force, and Germany had no answer to it. The Battle of the Bulge in December of 1944 provided the final, definitive demonstration of American engineering superiority. Hitler's last major offensive in the West caught Allied forces by surprise and initially achieved significant gains. German panzer columns broke through American lines in the Ardennes forest and drove westward, attempting to split the Allied armies and capture the vital port of Antwerp. The offensive depended on speed. German planners knew they had to reach their objectives before American reinforcements and supplies could arrive. They assumed, based on their experience earlier in the war, that American logistics would be slow to respond. They assumed that winter weather would ground Allied aircraft and negate American air superiority. They assumed that the difficult terrain of the Ardennes would slow American engineering units and prevent rapid reinforcement. Every assumption proved wrong. Within 24 hours of the German attack, American engineering battalions were already responding. Units that had been resting in rear areas received orders to move to the Ardennes. Within 48 hours, American engineers were improving roads to handle the massive flow of reinforcements moving toward the battle. Within 72 hours, temporary bridges were being constructed to replace spans that German forces had destroyed or American forces had demolished to slow the German advance. The German offensive created a bulge in the Allied lines, which gave the battle its name. American forces fell back but did not break. And then the engineering effort began that would doom the German attack. The town of Bastogne became the critical point in the battle. Surrounded by German forces, the American garrison at Bastogne held out, preventing German units from using the road network that converged on the town. But holding Bastogne meant nothing if the garrison could not be supplied. American engineers built or improved roads through the Ardennes forest that allowed supply convoys to reach positions from which supplies could be flown or trucked to Bastogne. When German forces cut one route, American engineers opened another. When weather prevented aerial resupply, American truck convoys pushed through on roads that had not existed a week earlier. The garrison at Bastogne never ran out of ammunition. They never ran out of medical supplies. They never ran out of food. American engineering had kept them supplied despite being surrounded by enemy forces. General Hasso von Manteuffel, who commanded the 5th Panzer Army during the Bulge offensive, later described his growing realization that the attack had failed. It was not a single dramatic moment. It was the accumulation of small observations that added up to inevitable defeat. German units captured American supply dumps and found them full of ammunition, fuel, and rations. German soldiers ate American rations and marveled at their quality and abundance. Chocolate bars, canned meat, cigarettes, coffee. These were luxuries that German soldiers had not seen in years. But more significant than the quality of American supplies was their quantity. Von Manteuffel watched his panzer divisions run out of fuel within days of the offensive beginning. The operation had been planned around captured American fuel supplies, but American engineers had either evacuated the fuel dumps or destroyed them before German forces arrived. Meanwhile, American units that should have been short on supplies after the surprise attack seemed to have unlimited ammunition and fuel. Von Manteuffel realized that even if his panzers broke through to Antwerp, even if they split the Allied armies, they could not win because they could not sustain operations. The Americans would keep building roads, keep running supply convoys, keep repairing bridges, and keep delivering the material needed to continue fighting. Germany could win tactical victories, But tactical victories meant nothing against an enemy who could absorb losses and continue attacking with undiminished strength. By late December, the German offensive had stalled. By early January of 1945, American forces were counterattacking. By the end of January, the Bulge had been eliminated and the front lines restored. Germany had lost over 100,000 men, killed, wounded, or captured. More critically, Germany had lost hundreds of tanks, thousands of vehicles, and vast quantities of ammunition and fuel that could never be replaced. The offensive had consumed Germany's last strategic reserve and accomplished nothing except to delay the inevitable. The final act came at the Rhine River in March of 1945. The Rhine was Germany's last natural defensive barrier in the west. German forces had destroyed every bridge across the river to prevent Allied pursuit. Every bridge except one. On March 7, 1945, American forces from the 9th Armored Division discovered that the Ludendorff Bridge at Remagen was still standing. German engineers had prepared the bridge for demolition but had not yet destroyed it. American troops rushed across under fire. German engineers frantically attempted to blow the bridge. The demolition charges detonated but failed to drop the span. American combat engineers immediately began working to secure the bridge and prevent its collapse or destruction. They cut German demolition wires. They removed unexploded charges. They reinforced the damaged structure with timber supports. They constructed anti-aircraft positions to protect the bridge from Luftwaffe attack. And then they started building additional bridges. Within 24 hours of capturing the Ludendorff Bridge, American engineers were already constructing a tactical bridge upstream from Remagen. Within 48 hours, they had completed a second bridge. Within a week, they had built a third bridge. The Germans threw everything they had at the Remagen bridges. Luftwaffe aircraft attacked repeatedly despite overwhelming American anti-aircraft fire. German artillery shelled the crossing sites around the clock. German frogmen attempted to destroy the bridges with explosives floated downstream. Special forces tried to infiltrate American lines and sabotage the spans. Nothing worked. American engineers kept building. The Ludendorff Bridge itself finally collapsed on March 17, 10 days after its capture, weakened by German demolition attempts, American traffic, and ongoing German artillery fire. By the time it fell, killing 28 American engineers who were working on it. For other bridges were already in operation at Remagen. American forces were pouring across the Rhine faster than German units could establish defensive positions. Within 2 weeks, American engineers had constructed over 60 bridges across the Rhine River. 60 bridges. Each one capable of handling the heaviest tanks and vehicles. Each one built under combat conditions, often under enemy fire, in a matter of days. German commanders simply had no frame of reference for this kind of engineering capability. German doctrine assumed that a major river crossing required weeks of preparation, specialized equipment, and favorable conditions. The Americans crossed the Rhine in multiple locations simultaneously and barely slowed their advance. Field Marshal Gerd von Rundstedt, commanding German forces in the west, sent his final assessment to Berlin in late March. The report was blunt to the point of insubordination. Von Rundstedt stated that continued resistance in the west was militarily pointless. American forces possessed overwhelming material superiority. More importantly, they possessed the engineering capability to exploit that superiority at a pace that made German defensive efforts futile. Every defensive line could be outflanked. Every river could be bridged. Every destroyed road could be repaired. The Americans simply built their way through every obstacle. The report included a passage that revealed the depth of German miscalculation about American military capability. Von Rundstedt noted that German intelligence before the war had assessed American forces as technically competent but lacking the warrior spirit necessary for sustained combat. The assessment was based on American performance in World War I, where American forces had arrived late and fought for only a limited time. German officers assumed that American society, focused on commerce and comfort, could not sustain the sacrifices required for total war. This assessment had been catastrophically wrong. American engineering units had demonstrated not just technical competence but relentless determination. They worked under artillery fire. They continued construction during air raids. They rebuilt bridges that were destroyed before they were completed. They operated heavy equipment in conditions that should have made such work impossible. And they never stopped. Von Rundstedt noted that German forces could fight bravely and die heroically, but they could not compete with enemies who simply rebuilt everything faster than it could be destroyed. The final weeks of the war in Europe saw American engineering units racing across Germany, building the infrastructure for occupation even before combat operations ended. They repaired railroads, restored bridges, cleared roads, and re-established utilities in captured cities. German civilians watched American construction equipment work and finally understood what their soldiers had been facing. One German civilian, interviewed years after the war, described watching American engineers rebuild a bridge in his town. The bridge had been destroyed by retreating German forces. Under normal circumstances, rebuilding it would have required months of work by the town's construction companies. American engineers had the bridge operational in 6 days. The civilian watched them work in shifts, using floodlights at night, operating massive cranes and bulldozers, assembling prefabricated components with mechanical precision. He said it was like watching a factory produce bridges instead of automobiles. When Germany surrendered on May 8, 1945, American engineering battalions were already deep into the next phase of operations. They were establishing occupation infrastructure, beginning reconstruction of destroyed facilities, and preparing for the possibility of redeployment to the Pacific Theater. They did not slow down. They did not pause to celebrate. They simply continued working because that was what they had been trained to do. The post-war interrogations of German officers provided the most detailed assessments of what American engineering had meant to the war's outcome. These were not casual conversations. The United States Army and Army Air Forces conducted systematic interviews with hundreds of German generals, field marshals, and staff officers. The goal was to understand German perspectives on the war and learn lessons that might be applicable to future conflicts. When asked about American military strengths, German officers consistently highlighted engineering capability. It was not the answer American interrogators expected. They anticipated discussions of tactical innovation, superior equipment, or effective combined arms coordination. Those factors were mentioned, but repeatedly, German officers returned to the theme of American engineering and logistics as the decisive American advantage. General der Panzertruppen Hermann Borch, considered one of Germany's most skilled tank commanders, provided an assessment that was remarkably candid. Borch stated that in tactical terms, German and American forces were roughly equivalent. German soldiers were perhaps slightly better trained for combat. German officers had more experience. German tactical doctrine was sophisticated and effective. But none of that mattered because the Americans could bring more force to bear at any given point than Germany could match. Borch explained that this was fundamentally an engineering problem, not a tactical one. American engineering units created the conditions for American tactical success. They built the roads that allowed rapid reinforcement. They constructed the bridges that enabled flanking maneuvers. They established the supply systems that kept American units fighting when German units would have been forced to withdraw due to lack of ammunition or fuel. Tactical brilliance meant nothing against enemies who could simply overwhelm your positions with superior numbers made possible by superior logistics. Colonel General Alfred Jodl, who had served as chief of the operations staff of the German High Command, offered a broader strategic perspective. Jodl noted that Germany had entered the war with significant advantages. German forces in 1939 and 1940 were tactically superior to their opponents. German operational doctrine was more advanced. German combined arms coordination was unmatched. These advantages had produced stunning victories in Poland, France, and the early Soviet Union. But Jodl argued that Germany had fundamentally misunderstood the nature of modern industrial warfare. Wars were no longer won primarily through tactical excellence or operational brilliance. They were won through the ability to sustain operations over time, to replace losses, to maintain supply lines, and to build faster than the enemy could destroy. Germany had focused on perfecting the instruments of war while America had focused on building the infrastructure that made war sustainable. The clearest example, Jodl suggested, was the difference in how the two nations approached bridge construction. Germany had trained elite pioneer units to build elegant, efficient bridges using sophisticated engineering principles. These bridges were marvels of design, using minimal materials to create maximum strength. German engineers took pride in their craft. But American engineers did not care about elegance. They cared about speed and functionality. An American Bailey Bridge was crude compared to a German custom design, but it could be built in a tenth of the time using standardized components that required no specialized knowledge. Multiply that difference across thousands of construction projects, Jodl argued, and you had the fundamental reason for Germany's defeat. Germany built beautifully. America built fast. And in modern war, fast beat beautiful every single time. Field Marshal Erich von Manstein, considered by many to be Germany's finest operational strategist, was asked during his interrogation what single factor had most contributed to German defeat in the West. His answer was immediate: American engineering capability combined with unlimited industrial production. Von Manstein explained that he could design brilliant operational plans. He could maneuver forces skillfully. He could exploit enemy weaknesses tactically. But all of that became irrelevant when the enemy could simply build their way out of any difficult situation. Von Manstein described observing American forces in the final months of the war. When American units encountered a destroyed bridge, they did not stop to figure out how to cross the river with available resources. They simply built a new bridge. When American forces faced a roadblock, they did not search for an alternate route. They sent bulldozers to remove the obstacle, or they built a new road around it. This approach required enormous material resources, but America had those resources and Germany did not. The field marshal noted that German forces had been trained to be resourceful, to accomplish objectives with limited means, to improvise solutions when standard methods were not available. These were valuable skills when resources were constrained. But they were unnecessary skills when resources were abundant. American forces rarely needed to improvise because they rarely lacked the equipment or materials needed to solve problems through straightforward application of engineering principles. Perhaps the most psychologically revealing testimony came from General der Infanterie Gunther Blumentritt, who had served as chief of staff to several senior commanders in the West. Blumentritt described the moment when he personally understood that Germany would lose the war. It was not during a major battle. It was not when a key city fell. It was when he reviewed reconnaissance reports about American construction activities behind the front lines. The reports detailed American engineering work in areas that had been captured weeks or months earlier. The Americans were building permanent infrastructure. They were paving roads with concrete. They were constructing warehouses with steel frames. They were installing telephone networks with buried cables. They were establishing facilities that would still be useful years after the war ended. Blumentritt realized that the Americans were not just fighting to defeat Germany. They were building the foundations for post-war occupation and reconstruction. This long-term planning, supported by unlimited engineering resources, demonstrated a confidence in ultimate victory that Germany could never match. German forces were struggling to maintain supply lines from one week to the next. American forces were building infrastructure that would last for decades. The psychological impact was devastating. How could Germany defeat enemies who were already planning what they would build after Germany surrendered? The Strategic Bombing Survey, conducted after the war to assess the effectiveness of Allied air campaigns, included extensive interviews with German industrialists and economic planners. These interviews revealed that German economic leadership had understood American industrial superiority from the beginning but had convinced themselves that German technical quality would compensate for American quantitative advantages. Albert Speer, who served as Minister of Armaments and War Production, admitted in his interrogations that German planners had drastically underestimated American engineering education and industrial flexibility. Speer had toured American factories before the war as part of an industrial delegation. He had been impressed by American mass production techniques but had dismissed them as only suitable for consumer goods, not precision military equipment. This assessment proved completely wrong. American industry applied mass production principles to military engineering with devastating effectiveness. Standardized components, modular designs, and assembly line techniques produced military equipment at rates that seemed impossible to German observers. More importantly, American engineering education produced a workforce capable of operating and maintaining this equipment under field conditions. Spee noted that Germany had approximately 200,000 trained engineers at the start of the war. The United States had over 700,000. By the end of the war, American universities and technical schools had graduated hundreds of thousands more, while German engineering education had been disrupted by conscription, bombing, and resource shortages. The disparity in trained technical personnel had been as important as the disparity in raw materials or industrial capacity. One particularly striking detail emerged from multiple German interrogations. German officers repeatedly mentioned their shock at how young American engineering officers were. In the German military, engineering command required years of experience and specialized education. Engineering officers were typically in their 30s or 40s, senior enough to have accumulated the knowledge necessary for complex construction projects. American engineering officers were often in their early 20s, fresh from university or technical school. They commanded engineering battalions that accomplished projects German officers thought should require much more experienced leadership. The explanation, German officers eventually realized, was that American engineering education actually prepared young officers to command construction projects. They did not need decades of experience because their training had given them the practical skills and standardized procedures necessary to manage large-scale engineering work. This was another example of the fundamental difference in approach. Germany had treated engineering as a craft requiring long apprenticeship and accumulated wisdom. America had treated engineering as a technical discipline that could be taught systematically and applied by relatively inexperienced personnel if they had proper training and standardized procedures. Under combat conditions, the American approach proved far more scalable and effective. The final chapter of German assessments came years after the war ended. In the 1950s and 1960s, American military historians interviewed retired German officers as part of broader studies of World War II. These interviews, conducted a decade or more after the war's end, revealed perspectives that had matured with time and reflection. Many German officers expressed regret not about losing the war, which had become inevitable, but about failing to understand earlier what they were facing. General Bork, in a 1960 interview, stated that if German leadership had truly understood American engineering capability in 1941 or even 1942, they might have sought negotiated peace before the situation became hopeless. By the time German commanders fully grasped what American industrial engineering could accomplish, it was far too late to change the war's outcome. The tragedy, according to these retrospective assessments, was that the information had been available. German intelligence had filed reports about American engineering education, industrial capacity, and construction capability. German officers who had visited America before the war had submitted observations about American infrastructure and manufacturing. But this information had been dismissed or ignored because it contradicted what German leadership wanted to believe. German military culture valued tactical excellence, operational art, and warrior spirit. These were the qualities that had made the German military the finest fighting force in Europe. But modern industrial war required different qualities: logistical efficiency, engineering capability, and industrial production. Germany had perfected 19th-century military virtues while America had developed 20th-century military capacities. There is a profound irony in the German experience with American engineering. The warnings had been there from the beginning. Intelligence reports in 1942 described American engineering education and industrial capacity. Combat reports from North Africa in 1943 detailed American construction capabilities. Assessments from Italy and France in 1944 quantified the disparity in engineering resources. Senior commanders like Kesselring and von Rundstedt explicitly warned that American engineering made conventional defensive strategies obsolete. But these warnings were ignored until the evidence became overwhelming, and by then it was too late to matter. German forces could not stop American engineers from building roads, bridging rivers, and establishing supply networks. German tactical skill could win individual battles but could not overcome the strategic reality that America could build faster than Germany could destroy. The post-war German perspective on American engineering was ultimately one of reluctant respect mixed with frustration. German officers acknowledged that American engineering units had been superbly equipped, well-trained, and relentlessly effective. They admitted that American engineering had been a decisive factor in Germany's defeat. But many German officers also expressed frustration that their own warnings had been ignored by leadership that preferred comforting illusions to uncomfortable realities. As Field Marshal Keitel stood in that Soviet headquarters on May 8, 1945, signing the instrument of unconditional surrender, he was surrounded by visible evidence of everything German intelligence had warned about. The American officers present represented a military force that had built its way across Europe. They had bridged the Rhine, paved roads through the Ardennes, constructed ports on Normandy beaches, and established supply networks that sustained millions of troops thousands of miles from home. What Keitel witnessed was not just military defeat. It was the final confirmation of a truth that German commanders had been told repeatedly but had refused to fully accept. Modern war was decided not primarily by tactical brilliance or warrior courage but by industrial capacity and engineering expertise. And in both categories, America possessed superiority that Germany could never match. The warnings had been accurate. The intelligence had been correct. The assessments had been sound. But they had been ignored because they were strategically inconvenient. German leadership had believed what they wanted to believe, and millions had paid the price for that willful blindness. If you found this exploration of German perspectives on American engineering valuable, please consider liking this video and subscribing to this channel. We are committed to bringing you historically accurate content based on verified sources, primary documents, and documented testimony. Share this video with others who appreciate understanding World War II from multiple perspectives, and leave a comment telling us which aspect of the war you would like us to explore next. Your support enables us to continue producing educational content that brings important historical lessons to new audiences.